This is Computer Science 455, Software Engineering. We're meeting today, the 27th of May, Wednesday. Okay? And we are going to talk about deadlines. As of now, all uh, um, we have all SPMPs being approved. The software architecture and design is, I gave my reviews to everyone about the software architecture and design, and I noticed several teams are having difficulty about the software architecture and design. The architecture and design is important in maintenance. There was a project that we have been maintaining for almost 5 years. And the team didn't document the changes in the design. So it's like a deck of cards. Uh, we built the system one on top of the other until uh, uh, 5 years hence, there was a problem in the software. And we tried to uh, uh, reverse engineer the software, but there was so many things that were done before that shouldn't have been done. And therefore, the software architecture and design is very, very important in continuing the project beyond the period we have now. And the worst thing that happened was we have to abandon the project. So it was a waste of the effort of building that software. And it was actually out in the commercial world. We are selling the software as an individual app, and we're trying to sell it to the counties of California. But we encountered a problem that we cannot solve. The only solution was begin from scratch. And I don't like that to happen. The software architecture and design is the blueprint, as I have said, of the structure of the major components in your software, their interrelation. The important thing is the major components and subcomponents and the interrelation among components. That's very important. And once you lose track of the design and you just keep building on top of each other every year of development, you will end up a software that can't be maintained, and therefore the software might end up being abandoned. That happens in software companies too, and they fall trapped to this particular um, method of software maintenance. Um, if you didn't maintain the software architecture and design, the following or succeeding teams will have harder and harder time to maintain the software. That is why this is very important that you learn how to um, come up with a software architecture and design of the current system so that next year we can continue the project with ease. So I have given you instructions on how to fix your architecture and design, and um, um, I'll give you up to the end of finals to fix your software architecture and design, because right now new deadlines are coming up and we can't spend more time on this particular task. So you have until the finals day to submit your revised software architecture and design. Okay, but now you have a grade. I gave it to you on your channels of what is the current grade for software architecture and design. Okay, we have completed the reviews of all test reports. I would like to commend the QA teams for doing an excellent job of specifying 3 test cases. One good test case, or 2 good test cases and 1 bad one. They define a bad test case as one that they didn't um, discover new errors or undiscovered errors, and the good ones are the ones that has a high probability of discovering an undetected error. So I commend them for making sure they have at least 3 test cases. So the teams have until the 29th of May, this Friday, to retest. Okay. As I said, I don't want you to spend more time on this, but of course you can continue working because prototype 2 or iteration number 2 will be based on what you build for iteration number 1 or prototype number 1. So you have until Friday, the 29th of May for retest. Okay. I'd like to remind you about the performance evaluation of the management consisting of the project manager, assistant project manager, and team lead. And team members, this is due on Friday, the 29th of May. And as I have said, the delivery and QA testing of iteration number 2 or prototype number 2 is on finals day. Okay, so those are the major deadlines that we have. All right. Okay, so let me remind you about the performance evaluation, because some of you are beginning to submit their performance evaluation, and I'd like to make sure that you understood my instructions. There is a leader survey which evaluates the management team, which consists, the development teams have management consisting of the PM and the APM. Okay, look at these arrows that I have here. A software engineer who is a member of that team will have a separate evaluations, one for the PM and the other for the APM. Is that understood? Each software engineer will have separate evaluations of the performance of the PM and the APM. The same with the other software engineers. They will submit 2 leaders survey, one for the PM and the other for the APM. Okay, so each software engineer will submit 2 evaluations, one for the PM and the other for the APM. I hope that is understood. Okay, now for the QA team, you only have the team lead. So each QA engineer will only submit, since there is only one leader survey to their team lead. Okay, so QA engineer number 1 will submit one leader survey for the team lead, and the other QA engineer will also submit just one performance evaluation for the team lead. Understood? For the leader survey. Now, for the member, I want the PM and the APM to get together and agree on the evaluation of their software engineers. So for the member survey, how the member perform their tasks, I want the PM and the APM have a combined report, just one report for every software engineers in their team. Okay, so I don't want separate reports. I want a combined report. The PM and the APM agreeing on the evaluation of a software engineer. Okay? And of course, for the QA team, since there is only one team lead, they will only submit a single performance. They're also going to do performance report, but since the TL, team lead, is the only management personnel, he will fill up a performance for every member of his team. Okay, so I want this evaluation report sent to me in the direct channel for my review. Okay, don't send it in the team channel. Send it directly to Dr. Concepcion. Okay? All right. Let's get out of this. Okay. So the next one is about cyclomatic complexity. I have given you a measure of the cyclomatic complexity of an algorithm. And the significance of this number, besides it is a metric, the cyclomatic complexity, the higher the number, the more complex the algorithm is. Okay? So the higher that number is the measure of the complexity of the algorithm. Okay? It also is it is also a measure of the number of paths, minimum number of paths that you can test in order to select test cases. Select test cases for your loop. As I have lectured last time, the testing 100% of all possible test cases, 100% of the test cases is impossible. Even for a simple loop that I've shown you last time, it will take years of doing testing. So it is not practical to do 100% of test cases. So this is a way to actually select test cases that guarantees that the loop, a path in the loop will be tested at least once. And that's the minimum required. You can do more, but this is the minimum number of paths that you will test. So the cyclomatic complexity, in addition to measuring the complexity of an algorithm, the higher the number is, the higher is its complexity. It also gives you a um, an upper bound of the number of uh, uh, path that you will test, that you can be guaranteed that each of the loop that you will exercise will be executed at least once. That's the requirement. Okay? So let's look at that example I gave you last time, where I gave you an example right here and challenge you to give me the cyclomatic complexity of this algorithm. Okay, so this algorithm is an averaging algorithm. So first thing we need to do is we have to label important parts of the algorithm, and we only label those that uh, introduces a branch. So if a line of algorithm executes, that is not important to us. Uh, what is important is the branching. If there is an if statement or a go-to statement, then that's what we would like to um, count. Okay? All right. So let's look at the algorithm and numbered those that are uh, um, uh, mark those instruction that introduces branching in the algorithm. So the first line of the algorithm is I equals 1, total input, total valid is equal to 0. All of this could be lumped into a single node, and we label it as 1 because they are not introducing any branching in the algorithm. We just lump them all together as a node 1 that constitute just execution. There is no branching. Okay. Then we encounter a do while here, and the do while has a limit of here undo. Okay, and undo we label that as 9. Okay? So the scope of the do while is at 9. Okay, that's the end of the do while. So what are the conditions of the do while? Both of these must be true. It's an and operation. So we label this one condition as 2 and the other condition is 3. Okay? So it only goes to 4 when both conditions are true, right? It's an and operation. Okay? Um, if it is false, then we go to um, we go to um, uh, uh, 4. We go to 4 if both conditions are true, and if they are false, we go to uh, 10. And 10 is this guy, the end of the undo while, right? So it jumps out of the loop because if either this is false or this is false, we get out of the do while. And that goes to number 10. Number uh, uh, number 10. That's outside of the undo. So this is 10, and that's going to actually outside of the do loop. So 10 is the node over here. Okay. So if both are true, we execute number 4, and then we jump to another condition, 5, another n here, and 6. So in order for the then statement to be executed, both must be true again. Okay? This is true and this is true. We execute 7. Now, notice here that these two statements, since they are execution statement, we lump it into 7. Okay? And if they are false, we false. If this is false or this is false, then we go to number 8. Okay, node 8, and this end if, the end of this if statement is this guy, and after that we increment I by 1, so we lump both of these together and call it 8. Okay, so next we have this if statement here. If this is true, then we go to 11. And if it is false, we go to 12. Okay? And then we end if, and we exit the program. Okay? So those are the labels according to the flow graph definition. Okay? So here is the flow graph. Okay? So we have 1 and 2, and 2 and 3. Remember, 2 and 3 is an AND statement, right? So AND statement, both must be true in order to go to number 4. Okay? And that's what we have here. 2 and 3, this is true. We ask, is this is true? Then 4. If either one is false, we jump to 10. See that? Okay. So looking back at the algorithm, if either one is not true, if 2 or 3 is not true, we jump to 10. Right? If both are true, we go to 4. Okay? So that's what is represented here. 4 is executed only when both 2 and 3 are true. And if either one of these is false, we go to 10. Okay? All right. So we have 4, and we have another if statement here. And this is 5 and 6. So 7 is executed only if 5 and 6 are true. 5 and 6 are true, and we go to 7. If both 5 and 6 are true, we go to 7. If either one is false, 5 is false, you go to 8. 6 is false, go to 8. We only go to 7 when 5 and 6 are true. That's what we have over here. Okay? And then you have let me see, at 8 is the culmination of number 7, it goes to 8. See, after 7, else skip, we don't do anything in there, so we lump it all together. Else means don't do anything. We go to 8, and from 8 we go to the next. Um, uh, we go to the 8 is an undo. That means we go to 9, and 9 is going back to the top of the do while. Okay. Right? So the undo will be the do while here, and 10 would either go to 11 or will go to 12. Okay? And they end at 13. Okay? All right? So we have the flow graph as given over here. Okay? So what are the cyclomatic um, uh, complexity measurement of this example? Okay? So we compute for the cyclomatic complexity VOG, and you have 17 edges. I will not count edges anymore. Last time I got lost counting because I couldn't see, I couldn't mark the edges, so I didn't know if I have counted it or not. But believe me, there are 17 edges. Okay. Um, 17 edges minus 13 nodes plus 2 equals 6. Okay? So the 6 independent path that must be tested at least once. So you select these test cases, this path, select test cases so that the test case will exercise this particular path. Okay? So path number 1 is 1, 2, 10, 1, 2, 10, 11, 13. Okay, let's do that. 1, 2, 10, 1, 1, 2, 10, 11, 13. And that's the end of it. The second path is 1, 2, 10, 12, 13. That's the second path. Okay? The third path is 1, 2, 3, 10, 11, 13, and 1, 2, 3, 10, 12, 13. Okay, but so that would be another path through it. Okay, the next path is 1, 2, 3, 4, 5, 8, 9, 2. So 1, 2, 3, 4, 5, 8, 9, and 2. Okay. Next one is 1, 2, 3, 4, 5, 6, 8, 9, 2. And the last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. Okay? So uh, you might have a 7 path, but 6 is enough to check for um, cyclomatic uh, complexity minimum number of path to check. So this is significant in terms of determining test cases to try. So with the cyclomatic complexity, you only need to um, select test cases that would exercise uh, the path, all the possible path in the program at least once. And you have 6 paths. You can test more, but this should be enough to test a path at least once. Okay, so that's the end of my lecture today. Since you guys have a lot of things to do, I will end my lecture here, and let me wish everyone um, to be safe and healthy.